Hi guys, welcome to Learn Electronics Repair, and I have something to review today. So this was sent to me by AliExpress free of charge as part of the sponsorship deal I have with them. However, my opinion of this power supply is going to be my opinion. I'm not under any obligation to say anything about this which I don't feel is correct, okay? So this is an honest review. What do we have? Well, this is a power supply R-SPS3020. So this is 0 to 30 volt, 0 to 20 amps. That's higher power than any of the ones I have here. I have a 5 amp one, which I use often. I have a 10 amp one also, which I use sometimes. So this is definitely higher powered than the ones I have. I do have several other power supplies on my bench. This is another one from Nice Power. I reviewed this one recently. This is a dual power supply, up to 121 volts, 3 amps on each supply, or you can use them independently like I have them set there, different voltages. That one worked pretty well. That's a programmable type supply, and I say it worked pretty well. In fact, it worked very well once I figured out how to actually use it properly, okay? This one is more of a simple design, a manual type power supply, which the other ones I have also are. That's the only programmable one I actually have. Okay, so let's take a look at this. It's quite chunky, there's some weight in that, and it comes with a selection of leads, okay? We have user manuals in Chinese and English. It's saying here, adjustable DC regulated supply, output voltage and current are continuously adjustable between 0 and the rated value. Stability and ripple factor of the power supply are very good and have a perfect protection circuit. It can work at full load for a long time, okay? Can be used as a regulated power supply or regulated current, so constant voltage or constant current. It gives us some specifications here, general explanation of the operation. This is the same as any bench power supply. Basically, if you've not used one of these before, I'm sure most of you have used one before, but with a constant current supply, you set a voltage, say 5 volts, and you set a current, let's say 1 amp, and as long as the current drawn by the load is less than 1 amps, you will get 5 volts. Once the current goes above 1 amp, or rather tries to go above 1 amp, the power supply will reduce the voltage to maintain the current at 1 amp. That's how these supplies work, okay? And it does this automatically. This is simply telling us how to connect the wires, the leads to the load, whatever you're powering with it, and just saying pay attention to the polarity. Okay, basic stuff. And it tells us here, non-professional charging equipment, please use it under human condition. Okay. Use under professional guidance. Non-professionals are not allowed to use it alone, and minors are not allowed to use it, and please make sure the input voltage is correct. You know, I'm sure when I was a kid, a minor, I would have loved this and I would have been perfectly capable of using it. Anyway, nobody else I knew anything about electronics, so who's to guide? So we have a nice big display, voltage, amps and watts, a constant voltage, constant current indicator, 2 knobs, adjust the current, adjust the voltage. These are rotary encoders, okay. They also press in, so we'll find out why that is, hopefully. Power, output, plus and minus, and there's a ground terminal, so you can also ground the item you're powering if you wish via this, as long as this is connected to ground on the mains as well, okay. Power button switches the mains on and off, and this output, I'm pretty certain, allows you to set the current and voltage you wish, and then when you want to power the device you were testing, you just hit the output button. You don't have to power this on and off. That's nice, okay, I like that. Now you'll notice this says maximum 5 amps and this is a 20 amp supply. Well, the reason for that is because on the back are 2 much larger connectors, okay. So they're saying to use the banana sockets on the front up to 5 amp, and then after that you use these. I'm not totally sure. I mean, obviously that's what they're saying. My 10 amp bench power supply uses the ones on the front, different brands, but I would be very skeptical of pushing 20 amps through here, so that's probably very nice, to be quite honest. The only thing, of course, is they are at the back, so if you have this, depending where it is on your bench, it might be a little bit awkward to get to those. You could, of course, extend this to something you can easily get to, but, you know, that just depends on your situation and your workbench. Let's have a look to see how much this costs. And here we are on AliExpress. There are various versions of this. I have the 30 volts 20 amps, so it's saying €134. I'll come to that in a moment. There is a 30 volts 30 amp version and others. If any of you guys are interested, I'm happy to try one of the other models. I can do that. So if you specifically want to see one of the other ones, this we can do. Okay, up to 120 volt 10 amp. That's the higher voltage of the 30 amp versions. That might be interesting, but hey, whatever you guys think, just let me know. When I say this price depends, it probably depends mostly on where you are. I had free shipping with the one I ordered, and if I go to my orders, you will see the power supply here. So I paid $97.19. The reason being, one, I am outside the VAT zone, European VAT, but the price I see listed on AliExpress includes the 21% VAT. It deducts it at checkout. And secondly, I use the coupons. So guys, use the AliExpress coupons and you can get the price down considerably. Okay. This also came with a free returns policy we have now. Not satisfied with your order, you can return it within the order protection period. Okay. First return on each order is free, so that's something nice now with AliExpress. You can buy with more confidence. Okay, keep that in mind. Let's put this through its paces then. So I'm going to use the supplied leads. These are banana plug leads with crocodile clips on. They feel quite nice, quite flexible. I'll just measure them and I'll tell you guys. Yeah, they're just over 1 meter long up to here, so we have a little bit extra there. So it's quite generous really. And these ones are slightly shorter, about 97 centimeters, so just fractionally under 1 meter. What I would like to do is check the accuracy of the voltage on this. I'll use my Alien Tech meter, 5 digit, it's quite accurate. Okay, we'll have a look at the ripple on the voltage rails with zero load, and then we'll try to get this loaded to 20 amps and have a look again at the ripple to see what it looks like and the voltage stability. Okay, and then lastly, let's open this up and have a look inside it to see how well it's built. Okay, so we'll check the voltages first. Okay, so I have this set to 5 volts 21 amps. The CC, constant current LED, is lit at the moment, so this control allows us to change the current. Okay, if we press the button, we can move to the next digit, press again, next digit, or even the top digit. So you can see you can very easily and quickly set the current to whatever you want the maximum. Okay, power, well, I'm on 5 volts, let's say go to 12 volts. It's very easy to set this accurately. Let's see what the multimeter tells us if we switch the output on. So it goes now to constant voltage mode, and we have 11.999. That is, well, 12. There you go. That's accurate enough for me. Let's just go up to the maximum voltage. So the maximum was actually 31, and we have 31.007. The maximum current also shows us 21 on here, by the way. Okay, so it's 21 amp. Let's try some low voltage. 1 volt. Now you'll see the capacitors are discharging from the higher voltage. That's why it's taking a little while for it to drop down. That's because there's no load on the power supply. Okay, normally you would have a load on the power supply. There is none. And we have 1.004. Again, I'm quite happy with that. What happens if I add 0.01 of a volt. Well, I get 0.01 of a volt. Let's try something we would not normally need to do. Let's go right down, initially to 0. I'll short the leads together. Okay, it's very close to 0.002 and dropping actually. That's very close. Let's put 0.01 of a volt. Well, that gives us 0.0009. So it won't go quite so low as that. You can see I'm adjusting 0.1 of a volt, 0.08, 07, 06, 05, 04, okay, 03. Yeah, 0.03 is the minimum, but come on guys, whenever you need a stable voltage lower than that, I mean 0.1, that's pretty impressive I think, and accurate enough for me. Let's have a look how much ripple we have on this. So I'm going to go for a fairly standard voltage, something like 5 volts, but we can see if the ripple does actually vary much with voltage. Okay, so 5 volts. Okay, and I have my scope on 100 millivolts per division. Okay, and I see a little bit of noise, VRMS 2.5 millivolts roughly of ripple there. Okay, so there's a little bit. Switch the output off. In actual fact, I think most of that noise is actually just coming from my workshop. Let me disconnect the scope probe from the meter. Yeah, that's with it off. So it is coming from the leads or something else, but I'm still seeing that even when the power supply is off. That's with the mains off. That's with the mains on. Yeah, so with the output on or output off, doesn't really make that much difference. So we have a little bit of ripple, but you know, there's not a lot of ripple there. Okay, let's put a load on this. Okay guys, so to test the power supply at 20 amps, Ohm's law says we need a resistance load of 1.5 ohms. So if we think about this, R equals V over I. Yeah, so if the voltage was 30 volts and the current was 30 amps, then R would equal 1. Yeah, in our case it's 30 over 20, which is 1.5, so 1.5 ohms. Now the resistance, if we do it this way, we'll have 30 volts across it and 20 amps going through it, so it will dissipate 600 watts. So the best way I can come to do that, I have 6 here resistors with something heavy on top. So each one of these is 100 watt, 1 ohm, so that gives us 3 ohms and 3 ohms, 2 in parallel gives us 1.5. okay, I'll put a little support under there and we'll rest this very heavy transformer on top, so that should hold the resistors down pretty well, transfer some heat out of them. The maximum dissipation for these is 600 watts and this is going to deliver probably close on that. We have some resistance in the lead, so maybe a little bit less. I have my oscilloscope attached, okay, and I'm going to measure the ripple current across the load. That's the easiest place to clip the leads basically from the scope. We'll switch our power supply on, and I have this set to 21 amps, 31 volts. That's a little bit over 600 watts, but I suspect we'll lose a bit because of the leads. Let's see if it actually goes into constant current. 17 amps, so that's what I'm going to get from this particular load. So I can't quite do the 20 amps, but this is fairly close. I have the scope on AC, but it's just going to take a little moment for the trace to come back down. So let's see if it lasts long enough to do this. Power on. I have 17 amps, 500 watts. Here we go. And we can see the ripple is about 27, yeah, less, 20 millivolts, maybe 10 millivolts. So actually there is less ripple under load. I'm sure my resistors will be rather warm now. Let's have a look. 60 odd degrees, 70 degrees. This one probably had the least cooling. That's why I couldn't run them for very long. So I don't actually have the facility at the moment to soak test this power supply, but we can see that the ripple is very good, even at close to full power. And as I said, we can take a look inside this. So we have quite a large cooling fan. I didn't hear the fan running. This must be temperature controlled. Quite a hefty switch mode power supply, as we would expect. Okay. Earthed, definitely. These are these terminals on the back, so very heavy wires. In fact, we have a inductor in there as well, effectively. Yeah, soldered straight down to the board. These look like the current shunts in actual fact for the constant current. They're quite beefy. Okay. I can just see under the edge of here, so it looks like power MOSFETs under there. You can see 3 legs. Yeah. So that looks like the cooling for the power MOSFETs. Again, nicely positioned by the fan, to be quite honest. This is a standby supply, I'm sure, so that's what powers this up when the output isn't on. So this is only running once we hit the output button, I would say, without investigating, but I would think probably. So this would be standby supply, and then all the logic is on the front here. Yeah, and thinner wires here, thinner wires. So I'm not really sure why we couldn't have had these big terminals on the front. Apart from it would have been a little bit larger, but other than that, I don't really see why. The earth, that's also bolted down to here. So that earth actually kind of goes through the chassis, the metal chassis of this. Although there may be a track on the PCB from here to here in actual fact. Okay, on the other side. Not totally sure that's the best arrangement, but if it bothered you, it wouldn't be very difficult to run an earth wire from here directly to there. You can see that's quite easily doable with this without even taking the PCB out. Okay, I've not looked into this before, but banana plugs and sockets could be up to 36 amp. However, I suspect not all banana plugs are equal. But I see others rated at 24 amps and such like. I had one on AliExpress, and I can certainly see sockets rated at 30 amps. So I don't really know for certain why they didn't just fit the sockets on the front for the high current. Especially considering the connections don't run through this PCB, they're just wired. This one is actually wired directly to the one on the back there. That one goes off over to the PCB here. So I don't really see any reason why we couldn't, for example, put another wire there, 2 in parallel, and another one from here over to there. May have to change these. I'm not sure how we would actually test or find the current capability of these. But I don't see why we couldn't have them on the front, and I don't really see why it wasn't designed that way. Because the only niggle I have with this is these big connections on the back, and not convenient for me. This would normally be on one of my shelves somewhere around the workbench, and I wouldn't easily be able to get to the back of that, okay? That might be a worthwhile mod. Let me know what you think about that down there in the comments, and maybe some suggestions towards this. Final thoughts on that. You know what I don't like? The connections on the back. Okay, but possibly we can modify that fairly easily. Could be worth a try. What do I like? It was very stable. Voltage was very accurate. So even down, I think, what do we get to? 0.03 of a volt. It was giving constant voltage. Certainly well below 0.1 of a volt. And that actually surprised me, to be quite honest. The interface is very simple, so there's no complex pushing buttons and so on with this. Just 2 rotary encoders, push them to go through the range of digits, turn them to adjust them. The output voltage switch, I really like that. I think all power supplies should have this, bench power supplies, and yet that's the only one of mine that does have. Okay, I couldn't test this up to 20 amps, basically because of the ability to make a load suitable. But I will be using this on my fake transistor destroyer, the one that actually tests the maximum current, and some of those transistors will go above 20 amps. So I'm sure we will get a chance to test that in the not too distant future. And the ripple was very low. In fact, there was more ripple without a load, which possibly makes sense because when there's a current flowing, it's easier to smooth, I think. You can talk about that down there. You can talk about the modification, and price wise I think this was pretty good. For the current capability, that was about the best I could find. We can try the 30 amp version if you wish, or one of the other versions, so if you're interested, let me know what else you might like to see from this range, and let's give them a go. Yeah. Finally, I'd be interested to know how many of you have bench power supplies of this sort of rating, what you use them for, or is there something you're interested in adding to your equipment? Okay, thanks for watching. I look forward to seeing you all soon on Linear Electronics Repair. Ciao for now, guys.